3.7 is on curve sketching. Really what this is a summary of everything that we've already done together. So what we learned was by analyzing the original function, this was in college algebra, by analyzing the original function, you can determine things like domain, x-intercepts, which is when y equals 0, a y-intercept, which is when x equals 0, and any horizontal and vertical asymptotes, which we've seen in the previous section. When we analyze the derivative of a function, that tells us intervals of increasing, decreasing, and because we found the intervals of increasing and decreasing, we could use the first derivative test to give us any relative extrema, any relative maxes or mins. By analyzing the second derivative of the function, we could determine intervals of concave up, intervals of concave down, and any point where concavity changes, which is called an inflection point. If we put all of this information together from the first original function, the first derivative, and the second derivative, we can actually determine the exact shape of a graph over a given interval without having to look at the graph using a graphing calculator or a tool such as Desmos. For instance, remember, if a first derivative is positive, the function must be increasing, and if a second derivative is positive, it must be concave up. If we put those two together, and we're thinking about concave up as a smiley face, analyze concave up. The first half, or the left half of a smiley face, if you had that shape, you would actually have you'd be decreasing, so that would be a negative first derivative. So that means because it has to be increasing and concave up, we have to be the right half of a smiley. So the shape of the graph would resemble the right half of a smiley face. Likewise, if our first derivative was negative and our second derivative was positive, we would have to be the left half of the smiley, concave up but decreasing. If we had our first derivative positive and our second derivative negative, we'd have to be increasing but concave down. Increasing and concave down is a frown. The increasing part of a frown is the left half. So that case would be the left half of a frown. If my first derivative was negative, again that means that my function is decreasing. My second derivative negative means that I have to be concave down. So if I'm negative, I'd have to be the right side of a frown. So these four shapes right here are extremely important to us. They're going to tell us the exact shape of the graph, and we can sketch a rough graph of the graph using the shape of the graph on any given interval, again without using any graphing tools whatsoever. Of course, I strongly recommend using graphing tools such as Desmos after you complete the problems to verify that your graph is accurate. We will not be exact on these graphs, but we will have the shapes and any important information for these graphs known through analyzing these steps. So if you analyze the function, the first derivative, the second derivative, we can summarize that into a chart, and then eventually the idea of step 5 would be connect all the information that we've decided and sketch a rough graph. Again, we're going to be sketching this graph without any use of technology until verification at the end.